Hi everyone, and welcome to the solution of our ecological project dealing with forest fires and their possible connection to arson crime. Please refer to the previous video which contains detailed description of the task. Here I am going to jump right to the question at hand, which is, based on the presented data which I prepared for you for most countries of the world, can you identify those which are soft on arson crime? If yes, it could have immense implications, because slight changes to the legal system can save the countries lots of CO2 emissions, lives, and money. Let's get into it. First, as always, is import of the modules. This time we are going to use pandas module, which is the workhorse of data science in Python, typically imported as PD. Second module is called WBG API, which creates an interface to directly access and import data from the World Bank. Very useful and easy to use thingy, which I will demonstrate to you. Then we have a pyplot module for plotting our graphs as PLT, and on top of that are built methods Venn2 and Venn3 to visualize Venn diagrams for 2 and 3 sets respectively. Now I have some additional notes which are important for any kind of data science task. First, collecting correct and reliable data can be the most demanding and time-consuming task. And even after investing lots and lots of time into this step, we can never be sure that our data is 100% correct. Second is, what are we going to do with the missing data? Many people might be affected by our studies, our conclusions, even without being included in the study itself. Philosophical question therefore for you is, how important do you think is for the world's progress to have a good quality and inclusive data for everyone in the world? And especially of course with the weight of the UN ambassador position, these considerations are extremely important. And I am saying this because data I collected and prepared for you do not adhere to these rules. And to make it more than just a playful project, we would need to address these issues. Now, enough of philosophy, let's get some coding done. Obviously, first thing is to import the table which I promised you. Tables in pandas are represented as so-called data frames, often shortcutted to DF, and they can be imported from many data structures and file types, one of which is CSV, comma-separated values, which you can get for example from Excel. And read CSV method has one required argument, which is the name of the file, in our case data_files.csv. With the second command, I set the index of my table, which will be the column called ISO. ISO is shortcut for International Standard of Shortcuts. And in our case, that's 3-letter code for every country in the world. And the in-place command tells pandas to make changes to my data frame directly, without creating a copy. After running a cell, as for any other variable, we can check the type. So let's type and our df, which will return pandas object and data frame. Data frame signifies that we have two-dimensional table, which means we have several columns in it. To see how our table really looks like, we can apply method head on our data frame, which prints several first lines, which can be specified by number, but the default is 5, which is perfectly fine for us. And we see how our table looks like. The first column, which is a little bit separated from the others, are the ISO codes of the countries. And that's how we are going to refer to our rows. And then we have the other normal columns, which are the country name, region, temperature change, I will explain what it means, average precipitation per year, and then of course we need some data regarding forests, total forest area and burnt area, both in hectares. Note that missing even a single column entry for a country means we cannot proceed with our analysis, so those have been already discarded. How many countries then we have the full data on? We can ask by asking for the length method of our data frame, which returns 120. How many countries are there in total? Almost 200, which means that we have data for 2/3 of the world countries and we are ignoring 1/3 of them. Now comes the time for second interlude of notes, this time about sources I use to get the data. If you are interested, check also the links because they contain much more good stuff there. Forest-related data comes from images acquired by NASA's Terra and Agua satellites. They are analyzed by scientists and then made available, for example, from Global Forest Watch website. From there we get total area of the forest per country, that's one number, and also burnt area in hectares, averaged between years 2012 and 2020. Regarding temperature data, I have downloaded them from Food and Agriculture Organization at United Nations FAO. Temperature data refers to temperature change compared to some base level, which is between years 1951 to 1980. Then again, I average the data between years 2012 and 2020 and compare them to 50 years ago, and that's the temperature change. Finally, precipitation data are available from the UN data portal, and they are in the form of millimeters of precipitations per year. Again, single number for each country. Let's move on to some coding again. We have to ask ourselves a question. How are we going to compare the burnt areas of the forest in between the countries? Because they have different sizes and also different areas of the forest, so we cannot compare absolute numbers. But what we can compare are fractions of the forest burned. You can also think about percentages. And that kind of fraction needs to be calculated, and we want to create a new column in our data frame, which is done by saying which data frame we want, that's our df, and then in square brackets we write the name of our desired new column, which is called fraction burned. And now we are going to say what the values are going to be equal to, which is dividing the burned area of the forest over the total area of the forest. So we need to refer to the first column of the burnt area of the forest here, which is again the f and square brackets and the name burnt area in hectares, and divided by total area. And there is an alternative way how to refer to the column, which is writing just dot and write the way the name of the column, this case forest area in hectares. This works only if you do not have any special characters on spaces in the column name. We can check again top of our data frame, df head. And last column is a new one, fraction burned, with very small numbers here. This is a fraction. If I would write here right away times 100, then I would be getting percentages. Now is the time to explain you the master logic we are going to apply to all our data. Based on our values of fraction of burnt forest, we can identify the countries which has this fraction high. That's the first set of countries. And those are candidates which potentially have a problem with the arson crime. Second set will be the countries where the temperature rise is not too high, because too high temperature rise could justify strong fires. Third set will be the countries where the precipitations are not too low, which could again explain extensive fires. With those three sets, we can do their intersection, which is basically saying give me countries which have decent rains, temperature is not rising crazily, but there are still lots of fires. And that will imply that maybe those are the real candidates for the big problems with the arson crime. I will show you the ropes now for the case of European countries. First we need to select them. For that we are going to create a new data frame df_Europe, which is derived from the original df, and the condition for the countries we want to put is that the column region is equal to string Europe. Note that there are two equal signs here for the conditional statement. Think of it also this way. With one equal sign, we are telling Python how things we want to have. Variables we want to be equal to something, or our new data frame, we want to define it in a certain way. With two equal signs, we are actually asking a question to Python. Are those things really equal? And if yes, put it please into my table. Now the question is, how much is a lot of burnt forest? You most probably don't know. I certainly don't, but we can let the data educate us. Because all we care about is to compare countries between each other. And for that we are going to use so-called quantiles. Imagine I want to split values into two groups of sizes which I want to choose. Let's say I want to choose 30% and 70%. Quantile is a value which will cut the group into exactly such parts. Example, if I write quantile 0.6, so that will be the value where 60% of my data will lie below that threshold, that quantile, and 40% of values will lie above. So quantile is a good way to compare countries relative to each other. Also note that quantile means the same thing as 60th percentile. Percentile is a method which you can find, for example, in the NumPy, and it's called NumPy percentile. So what we want to do now is to pick from the European countries the 30% of them which have the highest fraction of the burned forests. We are going to call it high burn limit, and it's going to be quantile. We are looking at European countries and the column of the fraction burned of the forests. And on those values we are applying the quantile, and we want to select 30%, therefore the quantile will be 0.7. After running the cell, we can print what the high burn limit is, and it is truly a number. Now you can see what I mean by saying let the data educate us. Beforehand, I had no idea what the high burn limit actually is supposed to be. Now I can see the number, and even more, I know that 30% of countries have the fraction of the burned forest higher than this number. Based on this value, I want to select actually the countries. The high burn countries we are going to select again from the European data frame, and the condition is that the values of the column fraction burn need to be greater than high burn limit, which is our quantile from before. And then last step is to convert the data frame into a set. That's done by the command set, then I put the high burn df, and I'm interested only in the ISO codes, therefore that's the index of our data frame, therefore dot index. Again, we can check how our set looks like, so set high burn, and it is really a set, you can see it by the curly brackets, and 3-letter ISO codes. Now we are going to repeat almost the same logic for our temperature change column. This time our quantile method will be applied to tchange column, with the slight adjustment that the value will be only 0.5. Then we are going to create a data frame, again from the European countries, and the condition is that the tchange column need to have values lower than the tchange limit. And final step is creating the set out of the data frame, again with the command set, from our newly defined data frame, not large tchange, and we are taking only the ISO codes, which is the index of the data frame. Let's print out what our set actually contains. Final repetition goes for our precipitation data. So precipitation limit from the European countries, of course, on our column of average precipitations, and applying quantile, this time again 0.5. The data frame will be defined very similarly out of European countries, and the condition is that Europe average precipitation per year, the values need to be larger than our press limit. Finally, our set not low press will be equal to the set, and out of the data frame we are going to convert again just the index, low precipitation df index, which is going to be again the set of ISO codes. Having all three sets, we are ready for our intersection logic. Before that, let's try it out with two sets only. That will be called inter2, and we are going to intersect the high burning ones with the not so large temperature change. So that's done by set high burn, and then we are applying method intersection and intersecting with the set of not large temperature change. When we print it out, inter2, we are going to get 4 countries. If you are not sure which countries these ISO codes belong to, we can use the log method from location, apply to our original data frame, which can select based on the index, which are our ISO codes, contained in inter2, only the rows which we are interested in. So running the cell, and we are getting 4 rows with exactly the same ISO codes as our inter2. As we have already discussed, the temperature is only one of the factors. because extremely low precipitations might also justify lots of burnt area of the forest. So we are going to do now the full intersection of all three sets, which is the set of high burning countries intersected first with the not large temperature change, and then chained on top of that intersection with the set of not large precipitations. We can list again the countries using the log method, log inter 3. And we are going out of 4, we cut down to 2 candidates, Portugal and Bosnia and Herzegovina. This is actually an encouraging result because actually I got the idea for this project when I saw on the news that Portugal recorded more than 2,000 arson crimes in the last 3 years. That sounded as a huge number to me, and then I started looking into some data about this. You can also perceive it this way. Precipitations could justify the fires in Montenegro, and what did we have there? The fourth country was Romania. Now we are going to visualize our free sets using a Venn diagram. I have already imported the method Venn3 for visualizing free sets with one required argument, which is a list of the sets we want to visualize. I have it here, and then some optional arguments, for example, setting labels for my sets, and I also define the alpha level with some transparency for our colors. You might recognize the structure of the Venn diagram, which illustrates how our sets are sharing the members, which are countries. Our first intersection was between high burn set and low temperature change. Those were these 4 countries, and intersecting the third, we kind of cut out this yellow part, 2 members, and we are left with the intersection of 2. For example, here we have 3 countries which are only present in the high burn set. So what we were after was this purple area here, and the other subsets could be derived by different combinations of intersection and union methods. This is the end of the first part of the project. In the next part, we will aim to compare countries across the whole world, not only Europe. It might of course appear unjust to compare such vastly different countries, and there are several ways how we might categorize them. We are going to use some developmental measure, which is the GDP. So hopefully see you there. Ciao!